Hi Year 12s, this is just a quick video going through this template for how to write up your design and deconstruct, which will be your last practical of the year. We want to start with our name and our SACE number and our school number. It's not 115, so check with your teacher, but you must include this as a header. We've just got some general hints here. We want to have full sentences. We want to have correct grammar. We want to make sure that we're using scientific language, which means we will not be using pronouns. Please make sure you check your spelling and grammar. We want to use a consistent tense for each section. So you can use present tense for the introduction, discussion, and conclusion. You just want to make sure that you have written each section of your practical in the same tense. So you could use a different tense for the introduction and the method, for example, but you must make sure your method is all in one tense and your introduction is all in one tense. You don't need a title page or a content page. Your font size should be no smaller than 9. And if you're going to convert to PDF, your page borders must be visible. You want to check before you hand it up that it's spaced out properly so that you have headings on the top of pages and you don't have bits all over the place. So you want to make sure you start your first page with a title, and your title is really the effect of the length of the carbon chain of alcohols on the change in molar enthalpy of combustion of biodiesels. You can word that in different ways, but that's what we're doing. You must make sure that you do your title as including both the dependent and independent variables. In the introduction, it does not need to be long, but you want to outline the context and some background and theory, any relevant equations, and the research question or aim of the investigation. So for this investigation, you might start with what is a biodiesel. You might say why there's so much interest in biodiesels these days, why biodiesels. You want to say why we're testing what we're doing and exactly what we are testing. You then probably want to introduce how you're going to test it and then a brief outline of the experiment. By brief, I mean 2 sentences. You then want a heading hypothesis, and that could be an if-then, or it could be as this happens, then this will happen. You need your independent variable. This should be a full sentence, and you should be able to get that from the title. You must make sure you specify in there, for example, if you are talking about different alcohols, what alcohols you're talking about. And then again, you want to put a full sentence for your dependent variable, and you want to include the unit for that. You are then going to put in a table on the factors held constant. You want to put the method of controlling, and you want to talk about the effect on the data, why we actually want to control this. So we want to make sure we include that very clearly. Then we've got extraneous variables, which are variables that are not going to be controlled. With these factors held constant, I really want you to think clearly into the method and think about your method, think about why we did each step of the method, and then with that, what particularly we want to keep constant within that. So you can think about the reaction conditions, you can think about the chemicals, you can think about how we did the actual experiment. Similarly, you're going to think about that with extraneous variables or factors that cannot be held constant. And you can use that as your heading if you want to. Factors unable to be held constant, you again are going to include a table. You can talk about why it couldn't and then what the possible effect on the data would be. You then want to put your apparatus. It's going to be quite long, you might leave a full page. You probably want one section for transesterification and then one section for combustion. Because we're using pretty inaccurate, really, equipment, we're not going to actually have to worry about decimal points like we did in our first prac. So you can use 250ml measuring cylinder, for example, or 1.25 litres of canola oil or 50 mils of methanol. You don't have to go 50.00. You then need to write your procedure. It should be very much stepped out. You probably will copy and paste this over from your deconstruct. You must make sure you're saying why you do every step. Your justification can be included in this section. Remember, it will not count to the word count. Again, you want to say, as we talked about in our volumetric prac, you want to say the volume of your equipment, and you want to say what you're measuring with that. You want to say the concentration if it's relevant. You can include an apparatus picture. This would especially be relevant for the calorimetry section if that helps you be a bit more concise. You could be doing this in a table, or you could do it step by step with some italicized justification below it. We're then going to write a risk assessment. Your risk assessment is probably going to go next. Some people will put the results next, but it makes sense to put the risk assessment next. You want to do your risk assessment, you can put all the alcohols together. Then you want to think about everything else, and you want to think about some of the equipment. You might also want to talk about ethical considerations. You do want to fill out these columns for each of these. You can refer to the MSDSs in order to be able to do this, and you do want to put some references in that. You can either put the reference in when you're talking about the hazard, or you might want to put it in this column here. You're then going to go into your results section. You want to make sure your results are clear. You will want to start in this prac with a table, and you want to make sure you have a very detailed table heading that goes on top. I really want to specify that. Table headings go on top, figure legends go below. So your table will probably look like alcohol used to synthesize the biodiesel, then your mass of sodium hydroxide that you use, your volume of sodium hydroxide, I should say, of potassium hydroxide, I should say, then your observations, then whether there was separation or not, your time taken to heat the water, and your observations on that. So within your observations table, you might do this in two tables, or you might put it into one. You want some observations around transesterification. So that first part of the practical, where we actually made the biodiesels and then we separated it out and purified it. And then some observations around the combustion. So you decide how you want to set that out. You probably want to include some photos in that to help you explain that. You then will, of course, want to include your results from your combustion. So that could be the time taken to heat the water, but it's also if you wanted to do that. But many of you wouldn't have timed that, and that's fine because you don't really need to measure that. What you should, though, have is a table where you've got the initial mass of the spirit burner, the final mass of the spirit burner, the change in mass of the biodiesel, the initial temperature of water, and the final temperature of water, and therefore the change in temperature of water. Okay, so once we've done that, we actually have to do calculations. Now, this is what I really want to discuss because the rest is pretty simple. We use canola oil, and that is actually composed of a variety of triglycerides. It contains approximately 65% oleic acid. And so you probably just want to say that as oleic acids constitute the majority of fatty acids in canola oil triglycerides, it was assumed that the primary triglyceride is a triglyceride comprised of those three oleic acids, as seen in a figure, and you could show a figure of that. Now, with that, some people, and this is where I specifically wanted to talk about this last year, or in the past, have actually taken into consideration the fact that it is made up of different things. So they might have used the fact that and done some research and found that it's made up of 60% oleic, and it's made up of 40% linoleic. I'm just going to put lin L because I can't remember exactly how to spell it. What that meant was, in order to do our calculations, of course, we have to find delta H. Now, you hopefully remember the formula for that. I apologize that this isn't working very well. And this is a formula. Now, we need the number of moles. To find the number of moles of our biodiesel, we need to do the mass, which of course we've found before, but we're dividing that by the molar mass. To find the molar mass of our oleic acid triglyceride, and when we're doing that, we want to think about, we've put methanol and oleic acid together. That forms an ester which is methyl oleoate. Okay? So remember, I'm just going to sketch this out, and it might be a good idea before your calculations that you do put a bit of a diagram. You start with your triglyceride, right, which looks a bit like this. It's like, forgive my terrible drawing. Oh, I should draw this nicely. But anyway, here's your triglyceride. Here's your general thing for your triglyceride. You're going to add into that, just going to raise this up here. You're going to add into that 3 lots of an alcohol. Okay. And I'm just going to draw this out. So what happens, remember, under the presence of a catalyst and KO and heat, we actually form glycerol over here. Always will form glycerol regardless of what alcohol we're using. But then we form our fatty acid mixture. Now we call this a mixture of fatty esters, all right? So this is actually broken down this triglyceride with 3 esters into this over here. Now, you might say, where is the CH3 coming from? The CH3 is coming from here. That's where the CH3 is coming from. That's why that's CH3. We have 3 of those that are formed. 3 different ones in this case because we've got 3 different R groups over here. And then okay, there you go. So if we've got methanol and we've got oleic acid, what we get actually produced is methyl oleoate. So when you're doing your calculations, what we want you to do is actually calculate what is the molar mass of methyl oleoate. You need to show you're working out for that. You can't just go onto Google and write it. M of methyl oleoate. Now this is what you do if you're going to assume that your molar mass of canola oil, you're going to take that as being the molar mass of methyl oleate, which is perfectly fine to do. That is going to be the molar mass of oleic acid plus the molar mass of methanol take the molar mass of water. Remember, hopefully you remember, that when we have this reaction happening, if you think about an ester being formed, and this is not exactly this, but it's equivalent to this, when you have an ester being formed, you have an alcohol losing an OH, and you get an H being lost off the acid. So this breaking down forms the same product as what would happen if we combined oleic acid and methanol and we took water out. So in order to find the molar mass of what we're working with, is going to be oleic acid plus methanol, take water. You probably want to write something about that. And so you want to show that working out really clearly. So you want to put that that's going to equal mass of, you want to write the formula for oleic, formula for methyl, formula for water. And then you'd want to do that's therefore going to equal 18 times 12.01 plus blah, blah, blah. And you'll do that for each of those. And you'll show you working out of where that came from in order to get your molar mass. Now, when you've got your molar mass, that's super easy now to be able to just find the number of moles and then use the delta H equation as before. The only thing I wanted to mention with that is that one, that's going to be different for each of your alcohols. So you're going to have ethyl oleoate, propyl oleoate, butyl oleoate, and pentyl oleoate. But also, some people decided that they wanted to be a bit more clever. It doesn't actually really add to it. So, I mean, bother if you want to. But if you find some reference on this, they did find that 65% was oleic, as I said, and 35% was actually methyl lineolate. So that's formed from linoleic. And so what they did was they found the molar mass of this one. They found the molar mass of that one. They did 0.65 times this one, 0.35 times that one, and added them together to come up with your final molar mass, which they then used. If you want to go the extra mile just for the sake of going the extra mile, good on you. Feel free. You don't have to. Okay? Hopefully that helps you with the calculations. Once you've, of course, done the calculations, you want to, therefore, graph that. And so you can graph that just doing a normal graph. Make sure you write a nice figure relation for that. You might, if you get a result that's really doesn't really work, you might want to take that out. And you might want to graph it again. So you might want to graph it with the original result. You want to put on your line of best fit. You want to put on your R-squared value. If it's not going to show a great trend and you've got one data point which is really out, you might want to take that out in order for you to actually be able to get a better result from this. So that's that part. Some people also went on from that, therefore, and looked at the true value so that they could compare it to a true value. And so that might be something as well that you want to do. There are ways of calculating true values. So you can do that. You can look into that if you want to, into how you actually calculate delta H. If you want to do that, you can. All right.